Okay, Assalamualaikum warahmatullahi wabarakatuh. Very good day to everyone. Okay, good afternoon, good day to everyone. Okay, all right. So we're gonna continue our lecture, but before this, I didn't finalize yet your attendance for last week because I think last week we kind of like just try and error our QR code system. So somehow or other I managed to get the thing. So I want you to aware later on. Wait, where is it? Okay, let me just. Right, so. Okay. So today, for your attendance, I want you to pay attention at your, at the content library. Okay, your content library, where you can see your attendance. Okay, does it come up? Okay. Later on, I will put the attendance for week 5 somewhere here in this folder. Okay, in this section. So please, I didn't finish analyze yet, but I have kind of like copy and paste put in a proper table, but I didn't put it in a OneNote yet. So I just want you to aware that because when I check the QR code attendance, so there are a few students who didn't scan QR code at all, like 0, and then I don't know, you forgot, or I don't know what is happening. So I hope, but I think for week 5 I think is acceptable because we just our first trial of the system. So I hope this week you will be better. Okay, at least like I said before, at least try to make it at least 2 times of QR code scan throughout the week. I know it's kind of like you can assume anything you want, but I hope honesty here say that means that once you scan the QR code, it shows that you are going through the notes, or you are doing exercise, you are open the slide, or you open the video and things like that. Okay, anything related to the course, it means that you deserve to scan the QR code. So minimum at least 2 times per student. Okay, you can scan more than 2 times, it doesn't matter, because it kind of is good actually, because it shows how often you go through the notes, or you go through the slide and video exercise and so on. Okay, so please take note that. All right, because at the end, because HEA, our academic at our campus, they kind of like monitor very closely in terms of students participation in terms of this online, because as you know, it's very difficult to trace either we lecturer really do online teaching or not, or to students participate or not, and things like that. So that's why it's very crucial for me to kind of like identify either you participate or you involve in the course. Okay, so using the QR code is a way of where I can really be flexible. It means I don't want to be very rigid, whereby you have to join the class, our online class like this, then I will take it as your attendance. So I try not to be that rigid lah. Okay, so please be aware of that. Okay, and then at least anytime throughout the week, because at the end of the week, normally like a Monday, I will kind of like reanalyze and really look back at your participation list, the attendance list, and then I will put it in your OneNote, just in case if say that I miss kind of like didn't notice your sometimes your tick and so on, I didn't record it properly, so you better check it yourself as well. So that's why I want to put it make it transparent with you guys, so that you can also check it out your participation. Okay, all right. Are you clear, Fatin? Is it okay?
Okay, madam.
Okay. Nur Aina and Balkis. I noticed your what you call that? Your assignment, not really assignment, assessment lah. We're talking about assessment, right? Your assessment, you did do it in your OneNote, but you didn't submit it in the team. Okay, so please make sure that you always, even though you, because I still gonna able to get your assessment, like be able to see your work, but sometimes the record is recorded in the team, either you submit or not. Okay, it's very important as well. So make sure that I don't know if you have any difficulty submitting the assessment through team, just please let me know lah. Okay, Aina and Balkis.
Okay, madam.
Yeah. All right. So let us continue our next lecture. Okay. So inshallah it's a very short one. Okay, so hopefully everyone. So because when I see your assessment, the assessment on Magna diagram, the example that I asked you to redo and so on. So I can see, I hope there's no, you guys are clear about how to construct Magna diagram. And then I do receive a question from WhatsApp during the weekend, which is good, alhamdulillah. So I know that you guys are, trying to do it, okay, trying to understand it, which is important. Okay, so anyone else who has any problem regarding the topic that we had gone through last week, please let me know. And then please take note, yeah, the assessment is, I put some kind of range, deadline and so on. It's not really a deadline. It's just matter of just to take note who submitted earlier, who submitted later, that's all. Because there's no marks given. So if you didn't want to do it, I cannot force you to do it. Okay, but then of course for you to be able to understand, because you need to do some practice, because this is a calculation. You cannot just read, and understand it directly. You have to try and do it yourself. So it's just a medium that I prepare for you so that you can do it and try it yourself. That's all. Okay, so don't feel stressed out with the task given. So it's not really like you have to submit it. If you didn't submit, then you don't get marks and so on. There's no marks pun sebenarnya and all. Okay, it's just a matter of for you to try and do it and then understand it yourself. That's all. Okay, and of course it's open. You can resubmit. You can submit it anytime you want. Anything that you think. But at the end of the normally I will relook back on the assessment that I gave. I wrote there formative assessment. So normally when I give that kind of assessment towards the end of the semester, I will relook one by one student, and see how many exercises that he or she did and things like that. You can also, not necessarily assessment that I gave, you can also put, any passes that you have tried and so on. Also, you can put it there. Okay, because if you have any question, also you can write it there. Okay, and then you take you WhatsApp me later, and then maybe I can check it dekat situ juga at the OneNote as well, and then I can give my own comment. Okay, also can be done. Shouldn't be a problem. Okay, so we start with our next method, which is tendon profile. Okay, all right. So at this point, what we have gone through before. Okay, generally when we have our, at this point we know already our E. Okay, at this point we know already our E, and we know already our pre-stress force. Okay, because through Magnell diagram that we draw or we construct, okay, we kind of like can identify what will be the range of pre-stress force that we want to apply to our pre-stress beam, and also the position of the tendon. Okay, the position of the tendon that we want to place for our pre-stress beam. So at this point, these two parameters, it kind of like we know already. Okay, so once we have our Magnell diagram, okay, next is where we justify it with another profile where it will reflect the behavior of the tendon throughout the length of the beam. Okay, so this we call as tendon profile. This tendon profile is actually, we want to kind of like see how the tendon behaves. okay, the shape, all right, the shape. So that's why it can be either straight line, and also we call as it can be parabolic shape. Okay, so normally parabolic shape or function is used to design tendon profile for post-tension members. Okay, why post-tension? Okay, because when you have pre-tension, okay, normally you don't have the profile. Okay, because when you pre-tension, because it's already concreting. Okay, if you remember the video that we watched before in the class, okay, when you have post-tension, we have the, what we call that, the conduit and the tendon is placed before the concreting, right? So when you have before the concrete, you see that there's a what we call the shape of how the tendon is laid throughout the length of the beam. Okay, so that's why mostly tendon profile is, we use it for post tension. Okay, means that we tension it after concreting. Okay, so the tendon are used to provide forces to the structures. Okay, all right. Of course, and cable is denoted as the resultant. Allah Akbar, sorry. The cable is denoted as resultant of all individual tendons. Okay, so normally we have more than one tendon, okay, in one beam. So then we call it as a cable where we have, multiple numbers of tendon. Okay, so instead of where we have, formative diagram, okay, normally formative diagram, we have it cross-section, right? Cross-section of the beam. Okay, where we estimate where is the neutral axis, and the position of the eccentricity, the E, and so on. Okay, so the what we call the relationship or the equation we derive from the section of the beam. Okay, but somehow or rather for tendon profile, we consider the length of the beam. Okay, the length of throughout the length of the beam. So we have two possibility where you could have a straight line tendon, which is the tendon will be straight, which is this is the E, okay, the eccentricity of it. Okay, and we also can have what we call as parabolic tendon. So when you have parabolic tendon, normally it will have 0 and 0 at the end of both side of your beam. Okay, and also you have the maximum eccentricity occur at the mid height of mid length of the beam. Okay, right. So we don't really have problem when the tendon is a straight line. Okay, we have issues in terms of estimating what will be the value of the y. For example, like this point, because when the tendon is parabolic shape like this. Okay, like what we see in the slide. Okay, so this is what we call when you have a post-tension beam. So normally we assume that the tendon will behave parabolic. So we assume that the tendon will have what we call as parabolic function. Okay, or quadratic. You're familiar with quadratic function, all right? Where y is equal to ax squared plus bx plus c. Okay, so at this point, we want to know what will be the y value. Okay, we want to know what's the y value, which is will be the a. Okay, and then the x will be the distance from the end to the mid length of your beam. Okay, and also you have your L, the actual length, and so on. So this is all the parameter. So how to get the values? Okay, we assume whereby x is equal to 0, y is equal to 0, c is equal to 0. So all equal to 0, y is equal to 0, c is 0, c is equal to 0. So at slope 0, 0, where you will differentiate this equation, then you will get this. All right, means differentiate against x, okay, x, then you will get 2ax plus b. So with 2ax plus b, and you assume your coefficient or your b is equal to 0, then you can conclude that at x is equal to L over 2, y is equal to a, and a is equal to 4al squared. Okay, so that is kind of like where you conclude, because you want to know what will be, at mid length of your beam, where your x here will equal to L over 2. Okay, So with that, then you conclude y is equal to 4ax squared over L over 2. So what we call that? This is A lah, the area, okay, for A divided by L power of 2. So you put everything, put here the parameter inside this equation, then you will get these values, okay, all right. I hope I'm clear. Try and put it inside the formula. If you have any problem, you let me know. Okay, location of the tendon. This is just to show you the location of the tendon. This is normally what we call as the permanent post tension tendon. PT is a post tension anchored on face. Okay, and kejap. Ada call. Okay, temporary PT bars and also stability tower. Kejap Hello. Yeah. Oh, belum lagi lah. Belum lagi lah maksudnya. Okey. So macam mana ya? Saya nak buat sendiri pergi klinik. Klinik swasta. Itulah itu sebab kalau boleh saya nak gambar. Tapi hari tu memang tak ada isu kan sebab memang ada tu. Betul memang tak main. Betul lah. Kalau saya yang dulu betul. Betul. Tapi kalau macam nak tunggu tu tak tahu. Itu lagi bahaya daripada tapi boleh terima kasih banyak puan. Tapi kalau saya ni memang tak ada apa-apa isu lah ya. Ya, ya. Allah, okay, sorry guys. Sorry, minta maaf banyak. I have to take the calls from the clinic, so that's why I kena ambil juga. Kalau tak, they cannot call back. Okay, alright. So I'm really sorry, minta maaf banyak. Okay, so we continue. Okay, where we are just now. Alright. So this diagram is just to show you where is the location of the common where we place the tendon. When we have this one is a common segmental section of a pre-stressed beam. Okay, and then we have a temporary post-tension bars and stability towers lah. This is very common. Okay, just to show you commonly where is the location of the tendon. Okay, why it's not moving? Okay, all right. So after pre-stress force determined and satisfaction at the critical section, so means that what we did for your, what we call that, the Magnell diagram, it is necessary to determine eccentricity at which this force must be provided, not only at the critical section, but also throughout the length. So in general, from Magnell diagram, we know the range. Okay, we know what we call that, what would be the range of suitable pre-stress force. We can check this is for economical or not and things like that. Okay, but for tendon profile is whereby you want to determine the eccentricity not only at the critical section. Okay, Magnell diagram identify E at the critical section because we consider it cross section. Okay, you know, the distance from the neutral axis, but also you want to know the E throughout the length. Okay, throughout the length of the beam. So that is why we need the tendon profile. Okay, so at any section along the member is the only unknown term in 4 expression. Okay, so in this case, for tendon profile, we're only going to be concerned with E value, with the eccentricity value. Okay, so, and this will be yield 2 upper and 2 lower limit, which must all be simultaneously satisfied. So we have 4 inequalities equation. Okay, 4 inequalities equation, but we're going to have only one unknown, which is the E value. So this requirement must be met at all sections throughout the member and will reflect both variation of moment, pre-stress force, and section properties along the member. Okay, all right. So generally we rearrange the equation. Okay, the previous equation, the 5, 6, 7, 8 equation. Okay, then we gonna make the E, as you can see here, as the main parameter which is placed on the left side of your equation. Okay, so the rest of other parameter is on the right side. So constant X value for constant cross section. So if the minor changes in pre-stress force is neglected. So if you notice here, this is what we call the constant of the cross section because these are all fixed. So see that this is only P naught. So if say that there was like change in terms of P pre-stress force value, so normally it will be neglected because it doesn't affect much in terms of estimating the E value, the eccentric for your tendon profile. Okay, so value changes respect to moment maximum and or moment minimum based on your bending moment diagram. So when you're talking about cross the length of the beam, you are actually talking about bending moment diagram. Okay, where you know where will be your moment maximum, where will be your moment minimum. Okay, especially when you have like what you call along the beam where you have a continuous beam. Okay, so if it's not, it's just a simply subtracted, so normally it's very straightforward. Okay, because you're gonna have 0 moment at both end, and then you have the maximum at the mid length. Okay, right. So you have moment maximum and moment minimum. So evaluate equation at any section to determine the range of eccentricities within which the resultant force P naught must lie. So if you look here, moment maximum, minimum are those relating to section being considered. So we're gonna calculate what will be your moment maximum and also what will be your moment minimum. Okay, for a member, a constant cross section, if minor changes in pre-stress force along the line are neglected, the term in bracket or in the expression are constants. Okay, so this is what we mentioned just now. Therefore, the zone within which the centroid must lie governed by the shape of the bending moment envelope. So it's shown as figure below. So if you look in the below, you will have something like this. Okay, along the beam, okay, along the beam, right? This is say that this is your, your beam cross section along the length. Okay, so you identify what will be your central axis. Okay, so what you see is, oops, tak appear kat you punya screen. Okay, all right. You will see like this line. You will see this line. Okay, this line. Where I try to draw it back. This is where, this is what we call as your tendon. Okay, your tendon profile at E. This is your equation. Equation 1. So the distance from this point to this point is where your moment maximum divided by K naught. Okay, or pre-stress force. Okay, so you have a second equation whereby you might have another profile. This is another tendon profile. Okay, and then you have another M minimum over pre-stress force. So the profile is normally what we call generate from the value of moment maximum and moment minimum, which will differentiate between one profile to another profile. Okay, right. So here is where you have the cross section equation that we mentioned in the previous slide. Okay, all right. So let's take a look on the example. It's actually not that it's quite straightforward to understand. Okay, so example 7 continue from a previous example as well, 4, 5, 6. Okay, so all the parameters still remain the same. Okay, so you have limits at mid-span and also ends of the member design. In previous example, for constant initial pre-stress force of 700 kilonewtons. So means we have decided. Okay, we have decided. Remember that from the Magnell diagram, we have the range of P naught. So if I'm not mistaken, P naught, we have the range of something like 1000 something. I don't remember, 1400 or something, like 400 something, like kilonewton plus like that. So in a range, so we decided to choose, we take 700 kilonewton. Okay, so and then probably having checked with economical pre-stress, is either economical or not. So we checked that and then we decided to take 700 kilonewton for this question. Okay, so we rearrange the formula. Okay, we take the E as your main parameter for to draw your tendon profile. Okay, all right. And if you look into this formula, why I did like this, okay, actually you can do this for, for pre-stress, for previous equation as well, because you look at this 4 equation is actually the same values, same z. This one is zt over a, this one is zt over a. All right, and then you have a parameter of what you call that, f dash maximum. So this is f dash maximum, and then this is f dash minimum. So zt, this is f dash minimum. So sometimes the difference is only in terms of plus minus. Okay, plus minus value. Okay, so it's good if you could calculate it separately, all the value, then you put it inside the formulation. Okay. Okay, and like this we have all values calculated. Okay. Later on, I will just give this assessment as for you to redo the example 7. Okay. And we have 2 conditions whereby in the question it says determine limit state at mid-span and also at ends. So in any question given to you or any condition given to you, you want to know at mid-span or at ends or both. So you have to just can identify it one by one. So for example, at this point, we identify it at the ends of the beam first. So we have at transfer, whereby you have this equation plus 0. You look at here is 0. Okay, at transfer and also at service. Okay, the same thing you have at 0. Why 0? Because, okay, why it is 0? Because you have plus minus, oh sorry. Okay, why 0? Because here is all moment. Okay, we have moment here. We have moment here. Moment maximum, moment minimum, moment maximum, moment minimum at transfer and also at service. So at end of the beam means at both end when the beam is simply supported, we consider as a simply supported. Then your end moment will equal to 0. So when this is equal to 0, so means that plus equal to 0. Okay, so that's what you see here. Now that's why you see every equation plus or minus with 0 at transfer and also at service. So you will get these values. Okay, for equation 16, 17, and 18. Okay, and at the end of the beam, this is where we lie within the range of 35 mm. So you can do the range of like, the E. So you have like E 654, 34, 64, 34. Then you have like minus 111. Here you have minus 58. You can do like, the thing that lies within the range, which range. Okay. All right. Hope you can try that later on. Okay, so something like this. This will be the range that you decided to choose based on this. Okay, that covers the equalities. So at mid-span, we consider this point at transfer. Okay, so at this point you have a value because we have the value of moment maximum and also moment minimum. So just bear in mind how to calculate your moment maximum and moment minimum. Moment minimum where you consider only self weight, and moment maximum where you consider all weight. Okay, and at the mid-span, the resultant of the must lie within 47.8 to 66. Okay, this is the values. All right, so when you want to draw, okay, this is where the thing that you want to you have a graph paper. Tendon profile also draw with graph paper to get accurate scale values. So in general, what you have at transfer and at service, you have equation 16, 17, 18, and also 19. Okay, so you have at mid-span and also at end span. This both value, meaning you have what we call that at end span and also mid span. Okay, this is end, this is mid. Right? Okay. So if you try to look together, how we gonna draw the thing. So in general, you have this as your height of your beam, your E. Okay, this is your height of your beam. Okay, so basically the height of your beam, we consider it just now is what we call 350, right? So here is already, we consider minus the, what we call the cover around 30 like that. Okay, 25, 30 like that. Okay, so this is the range that we estimate, okay, of your E. Okay, E, this is the midspan. Okay, 0, 0, sorry, not midspan, the neutral axis values, and then the E varies lah, 20. So it's like you draw a scale of your E throughout the height of your beam. Okay, and then this is the what we call the length. This is become your length of your beam. This is your L. Okay, so you draw one by one, which means that first you have equation 1. Equation 1 where you have it around minus, what we call that, minus 116.7. So somewhere here, you draw here minus, this is minus. You draw here first, minus 116.57. Okay, so you draw a straight line. For what we call for end span is where you can get a straight line first. Okay, then you draw 19, where here is what you draw 5, what we call minus 58.29. So this is where you can draw minus 58.29. Okay, so I'm sorry, it's a bit lag the drawing if you see. Yeah, I hope everyone can see. And then you have equation 17 where the value of the line here is 34.97. So this is the value. Okay, this is what you draw for equation 17. And equation 16 where you draw 64.12. So first you just mark, okay, at this point this is 64.12. So this is 34, at end of the span is 34. This is minus 58, this is minus 58. So this one is minus 100, this one is minus 100. So you draw a straight line first for all 4 equations. Okay, once you draw the, what we call that, the straight line. Okay, then you mark the what we call the mid length. Okay, this is the mid length. This is the mid length. Okay, the mid length of the length of the beam, the mid length of the beam. Then with the mid length, when you already mark the mid length, then you start to make a point. This is the point. This is one point. Say that I mark it is a green, as I put it here. It's a green, which is equation 18. It's a green color, which is this marked as minus 10.5. Okay, right? Then I mark second equation, which is equation 19. Here the color, I put it here as a red color, which is here is 47.78. Okay, right? Then I mark another color, which is a purple. I don't really have a purple, so I will just draw orange here instead. So somewhere here, so it's a bit confused with me. Okay, I draw blue. Okay, blue somewhere here, blue. Okay, which is this will be 66.26, which is this value, equation 17. Okay, equation 17. Alright, then I have another color, which is the orange one somewhere here, which is equation 16. This is will be 95.41. So if you look here, it's somewhere here. It's actually somewhere here. Okay, 95.41. So that's why it's very important for you to get you know, a good graph paper so that you can get accurate scale. Okay, so far you guys following me? Supri, okay?
Okay, madam.
Yeah. Who else? Fitri, okay?
Okay, madam.
Yeah, Jacqueline, okay?
Okay, madam.
Izati, okay?
Okay, madam.
Yeah. Okay, so once you identify the midpoint, okay, according to the values that you calculate for each equation here that you have, then you can start to join the line. So when you join from this end, okay, where's the point? Okay, from this point and you join, oh, I didn't show you. The line is a bit, they're a bit lax, okay. You can see the line, okay, like just me, we start back. Internet a bit slow hari ni katnya. Okay. Okay, then you have the midpoint. Okay, right, so you have the first line somewhere here. Okay. Alright, so you have this point at the end of the beam. Okay, you draw it and then you have it at midpoint here. This is the value. Alright, so and then you join it to the other side. So since this beam is what we call symmetric, because the section is the same, okay, so you kind of like having the same parabolic equation as you can see on the right side is similar with the left side. So it's kind of like a mirror, all right, mirror profile. So the same thing you do to the what we call to the equation 19, okay, and also Allahu Akbar, sorry. Because the internet is a bit lag, so that's why. Cannot see the line yet. So when you run your what we call the PowerPoint by yourself, you can see it clearly lah. Okay, and then you have the equation 17, equation 16. Okay. Okay, then you will see this. So you will see the inequalities bonded line where this is the point, the what we call as the zone, the range of the zone for your E. Okay. Today's line are quite bad. I didn't get a smooth. Okay, right. Okay, so here is whereby you will see the point, okay, of the distance of M maximum Kp naught from this point to this point, means from equation 19, okay, to this line of equation 17, and from equation what you call that equation 19 to equation 17, here you will see at the minimum P naught, which is 31.9. So yeah, okay, you see this point here. This is the point to here from here taken, and then this is the point taken from here value. Okay, sorry, the line is not so smooth today. Okay. Okay. All right. So what actually we conclude in this tendon profile that you see here, right? So you will have like the range, what acceptable is around 31.90. Okay, this is the so the E range is within this part. Okay, this is the range. Okay, so if you compare it with Magnell diagram, okay, you compare it with Magnell diagram, say that you have your E is equal to 48 just now, 48 mm. Okay, where did you get the 48 mm? Is where you conclude somewhere here. Okay, from the equation. Let me see, just show you back. Okay, somewhere here, right? This is where you get you conclude that the range is within 48. Okay, within 48 to 60, 47.8 to 60 mm, or we can say is within the what you call 48. Okay, and when you draw the, I think I'll just try not to do the slideshow. Okay, so here is whereby where is your 48 is within this now, right? So you have within 48 to 66 somewhere here. 66 somewhere here. Oh, sorry, 66 somewhere here, and then you have around 48. Equation 17 and also equation 18. This is the two equation that bonded. The zone is bonded by equation 17 and also equation 19. Okay, so you can see the same equation 17 and also equation 19. Okay, so the value will be 57.8 for equation 19. Okay, somewhere here. All right, bonded with value of what we call that, 66.26 somewhere here, equation 17. Okay, at the midspan, this value and also this value. Okay, and when you look, I hope you can see. Sorry, when I point it out, it doesn't appear in the slide that I share. Okay. Right. So say that we take one value, which is E is equal to 48, this value. Okay, this value. When you drag the E is equal to 48 value, and then you can confirm it by mentioning that the range of E 48 and 66 is still in the range of it didn't show lambat. Okay, lambat. Alright, so you can see the range of 48. Allahu Akbar. 48 and 66, the P naught is equal to 700 kilonewton. So remember that we, for this question, we give the value P naught is equal to 700 kilonewton, right? So we didn't, and then we put it, you include in the equation in terms of, come up with the tendon profile. So from the tendon profile, you get the range of 48 and 66. So basically, when you drag it to check in your Mendel diagram, you go to the right side of the scale of your Mendel, you get back your 700, which is what we have decided for your pre-stress beam. Okay, when you calculate your tendon profile. Okay, alright. Sorry for the lag lah. I mean the slide banyak lag sikit today. Okay, Syafiqah, can you follow me?
Okay, madam.
Boleh ya? Hopefully, I'm really sorry. I don't know why today the bit lag when I want to show the slide. Okay, but I hope you can still follow, or you can also try to redo. If you have any question, you can ask me back lah. Okay, Aidil, okay? Okay, Ain Farisha, okay? Okay, alright. Who else? Shakira, okay?
Okay, madam.
Okay, yeah. So what actually you can conclude from tendon profile and also Mendel diagram. Okay, so Mendel diagram is where a diagram where you kind of like construct it when you want to know the range of your E, what will be your suitable E, and also the range of your pre-stress force, your P naught. Okay, so once you already construct your Magner diagram, you also want to know the behavior of your tendon throughout the length of your beam. So when you want to know the behavior of your, your tendon along the beam, where you construct your tendon profile. Okay, so by constructing your tendon profile, you also will be able to get what will be the sufficient E. Alright, what will be your sufficient E value? Okay, E minimum and also E maximum. So so say that but if you don't have, of course you be able to do this, okay, through Magner diagram, because when you decided, okay, I want to use P naught, for 700, so you draw it in on your Magner diagram, you easily can drag down and then you will get the range of your E. Okay, yes, you can get your range of the E, but you wouldn't know the what we call the boundary of your tendon profile. Okay, it means that is it a straight line? Is it how much is the moment maximum? The drop of your tendon, the maximum deflection and so on. You don't know the profile, so you will want to know the profile of your tendon, okay, throughout the length of your beam. So that's why you need to know, need to have your, need to draw a tendon profile. You need to construct a tendon profile. So in here also you can be you know the relationship between tendon profile and Magner diagram, because they will give the same value. Like this, from the tendon profile, you estimate the range of your eccentricity, which you come up with E is equal to 48 and also E is equal to 66. That will be the range. So when you drag in the Magner diagram back, you still get back your 700, which you have decided for your pre-stress force for this question. Okay, so I think that's about it somehow. So if this is just to tell just to you can read this, the width of the cable zone. Okay, what will be the requirement, the minimum spacing, what to consider, and also I don't want to drag you to that so long, because it will drag the slide. Okay, so you can read that by yourself. So if you have any question, generally you can ask me back. Okay, so I will release just, okay, all right, and try and redo. The only way for you to understand is to redo. Okay, that's the only way that I can say. Sometimes due to our online thingy, the internet and so on, so sometimes it's not smooth. See, I experienced some lagging here, because when I already explained, I thought I already show it to you, but what you see is a bit lag. Okay, lambat dia punya the line keluar. Okay, so I will release assessment just to see how many of you doing it, okay, at home. All right, in terms of generate, it's not that difficult for you. You just need to redo the example. Just matter of you do it yourself, you plot it yourself, really understand how to calculate, punch the calculator yourself, and then check either you get it the same value or not, and things like that. Okay, so just copy back the question, okay, for the assessment. Then later on, because when you do calculation, it's important for you to write it back and really understand the how the value, you get the value. Okay, so any questions so far from you guys that maybe you want to ask? Okay, Aina, Shakira, any question? Okay, any questions, soalan? Sakina, soalan? Any question ya? Shahida, any question? Okay.
No, madam.
Alright. What else? Harisha, who else? Harisha, any question? Izati,
No, madam.
any question?
No, madam.
Okay. So I hope everyone is clear. If you're not clear, you can rewatch this slide. And then for you guys, for just to let you guys know, Okay, just to let you guys know, in the YouTube channel, I have uploaded other classes recorded session as well. So you might want to watch them, their slide juga. Sometimes, you know, when having 3 different classes, so I'm not a machine and all, right? So sometimes the explanation might be different, you know, maybe there's some point here, maybe I told your class, not their class, maybe I told their class, not your class, something like that. Okay, so you can also check that video and then just to rewatch it, you know, to have a different view and so on. Probably can give you more input and understanding to the chapter. Okay, so I think that's all for me from me today. So we're gonna meet again tomorrow, inshallah. Okay, for our lecture, 2 hours. If I'm not mistaken, tomorrow, right? 2 hours tomorrow or Thursday something. I pun ikut.
Tomorrow, madam.
Tomorrow eh. Okay, alright. So I'll meet you guys tomorrow, 2 hours. So we're gonna continue with our next lecture, which is pre-stress loss. Okay, but the good thing is because in pre-stress design, there are 2 main what we call that crucial thing will be Magnell diagram and tendon profile. And of course, you have bending moment calculation and shear calculation as well. But the core is normally Magnell and the tendon profile. Okay, so please what you call pay attention to that. And then your test 1 also we probably will focus more on either Magnell or tendon profile. Okay, so I think that's all from me. Thank you very much. So I'll be seeing you back tomorrow. Okay, right. Thank you very much. Assalamualaikum warahmatullahi. Take care, everyone.
Thank you, madam.
Waalaikumsalam,
Waalaikumsalam.
madam.
Thank
Yeah.
you.
Thank you, madam.
Thank you, yeah.